right, we're going to continue with the sum and difference formulas. So this is lesson 5.4b. And one difference is that the angles that we're going to be working with are, some of them are going to be in degrees. In the previous lesson, we focused on radians. And then we're going to be given the values of sine of U and cosine of V, and then draw triangles and then finish the problem. So same formulas, just slightly different use of the formulas. So for example 1, we're going to find the exact values of the sine, cosine, and tangent of 75 degrees. Okay, so a lot of the times when it's degrees, they don't tell you what angles add or subtract to give you that. For radians, they'll give that to you because it's slightly more difficult to figure out in your head. But for degrees, the special angles, the original special angles are 30, 45, and 60 degrees. And then any multiple of those is also considered a special angle. I think that you can figure it out on your own. So with that in mind, the first things I think of for 75 degrees for a sum or a difference is 30 degrees plus 45 degrees. Now, there is not the only one. There are other angles that will add or subtract, special angles that will subtract to give you 75 degrees that you could use and still get the same answers. All right, so let's start with the sine. The sine of 75 degrees is going to be the same as the sine of 30 degrees plus 45 degrees. All right, so then we're going to use this first formula, and we're going to let 30 degrees be U, and we're going to let 45 degrees be V. All right, so I'll just plug in our 30 degrees and our 45 degrees into the formula. Okay, and I want you guys to know that you can do the hand trick for degrees. So the hand trick works for radians and degrees. You just need to know what angle is what in degrees. So 0 radians is the same as 0 degrees. And then as you move up, they're basically, the special angles are going in order. So 30 degrees, and that the way I've drawn it, it kind of looks like it's drawn at a 30-degree angle. And then 45 degrees, 60 degrees, and then 90 degrees. All right. And so if I want to find the sine of 30 degrees, I've been 30-degree angle, and there's one bottom finger over 2. All right. And then the cosine of 45, I've been the 45 degrees finger, and it's the top, so it's the square root of 2 over 2. Right. For cosine of 30 degrees, I use the 30-degree finger. There are 3 top fingers over 2. And then sine of 45 degrees, there are 2 bottom fingers over 2. Okay, and it's just like what we did yesterday. So for each set of those fractions, we're going to multiply across the numerator and across the denominator. And then we would want to write that as one fraction. All right, now we're only a third of the way done. We're also going to do this same thing for cosine of 75 degrees. So the cosine of 30 degrees plus 45 degrees. All right, so I'm going to pull this guy down. Okay, so we are going to use the cosine of a sum and put 30 degrees in for U and 45 degrees in for V. All right, so then we'll just use our hand trick, which we've probably already found all of these things above. Okay, so the exact value of the cosine of 75 degrees is this. And I'm sure you've noticed, like as you did your assignment, that you kind of get the same things over and over and over again. Because there's only so many combinations of what you get for sine and cosine of those special angles. All right, and then lastly, we're going to do the tangent of 75 degrees, or the tangent of 30 degrees plus 45 degrees. Now, tangent does seem to be the most complicated one, I would say. Because you have all these, like you have fractions inside of a fraction, and then you have radical in the denominator, so you really do kind of have to work with it a little bit more than the others. All right, so then I would use the 30-degree finger to find the tangent, and that's going to be the square root of 1 over the square root of 3, which reduces to the square root of 3 over 3. All right, and then for tangent of 45, it's the square root of 2 over the square root of 2, which is 1. Right, and then I'll just use those again in the denominator. When I do the square root of 3 over 3 times 1, it's the square root of 3 over 3. All right, so this is one of the ones that I have this radical in the, I have a fraction inside of a fraction. And so what I'll do is I'll just multiply through by the 3. So we'll distribute it on the numerator and in the denominator. When you do that, you get rid of the fractions. Okay, and then there's one more thing I need to do now is to get rid of the radical in the denominator. And the way to do that is to multiply by the conjugate of it. So instead of 3 minus the square root of 3, it's going to be 3 plus the square root of 3. All right, so in the numerator, we distribute all of that. And distribute the square root of 3. In the denominator, I can do a shortcut. All right, so then I will just combine my like terms. So 9 plus 3, 3 square root of 3 plus 3 square root of 3. Same thing in the denominator, subtract. And then these kind of all work out the same also, where all those numbers can now reduce by 6. All right, so lots and lots of interruptions. That's okay. I reduced by 6. And there it is. All right, and you see those again, that same answer, maybe with a -2 or maybe with a negative square root of 3, but you see those same answers over and over again. Okay, so that wasn't super new. I mean, that was just doing the same things, but just a longer problem because you're doing all of the ratios. But on example 2, which is going to be kind of new. So for example 2, we're going to find the exact value of the trig expression given that the sine of u is -7/25. The cosine of v is -4/5. And both u and v are in quadrant 3. All right, so the first thing that we need to do is draw these triangles. So you're going to have a triangle for u and then a separate triangle for v. All right, so they're both going to be drawn in quadrant 3. And when you draw an angle out of quadrant 3, come out of the origin and then you go to the x-axis with your right angle. So we'll call this one u, we'll call this one v. And what we know about u is that the sine is -7/25. So that means the opposite is 7 and the hypotenuse is 25. Now this is actually a Pythagorean triple that you may or may not know. We kind of reviewed it a little bit for the ACT, but this side is going to be 24. Right, and then for v, I know that the cosine is -4/5, so I know that the adjacent is 4, the hypotenuse is 5, and that's going to make the opposite 3. Okay, now what you'll be given is something to find, and what we're going to find first is the cosine of u plus v. All right, and so what we would need to do, I'm going to grab my formulas. Basically, all we need to do is just write down the formula. So cosine of u plus v is this one. So it's going to be cosine of u cosine of v minus sine of u sine of v. And I have to be careful because a lot of times my u's and v's look like the same letter. So make sure you can distinguish between them. Okay, so that means from this triangle, I need the sine and cosine of each of these. So I know that the sine of u is given to me, it's -7/25. But I can find that the cosine of u is -24/25. Right, and then for my v triangle, I can find that the sine of v is -3/5. And the cosine of v, if we're told, is -4/5. So what I'm going to do is just plug those in. So in the place of cosine of u, I'm going to write what the cosine of u equals. And in the place of cosine of v, I'm going to do the same thing. Right? And then same thing for the sines of both of those. Okay. All right, so now it's just dealing with these fractions. All right, so I'm going to, when you guys do this, you can use your little blue calculator, but we're going to multiply across the numerator. So negative times a negative is going to be +96. and across the denominator. Right, and then on this one, when I multiply, it's minus, and then when I multiply negative times negative, it's 21 for 125. All right. Then they have a common denominator, which is what I really wanted. And so when I subtract, I get 75 over 125, and both of those will reduce by 25, and I get 3/5. So that is the cosine of a whole new angle that you would get by adding this u with this v. That seems like a kind of weird thing to need, but who knows? Okay, let's do another one. The tangents are definitely more difficult, as you guys can imagine. You have all these fractions inside of a fraction stuff to worry with. All right, so we're gonna find the tangent of u minus v. So I'm going to start off and write my equation for that. Okay. Cool. Now I'm going to go back to my triangles. I hadn't found the tangent, so we'll do that real quick. So the tangent of u is going to be the opposite over the adjacent, and in quadrant 3, tangent's positive. And then same thing for v, the opposite over the adjacent, and quadrant 3 is positive. Okay, so let's take those and let's plug them in. For tangent of u, I'm going to fill in my 7/24, and tangent of v, same thing. Okay, so my advice to you on these is to hold off on that numerator. Just leave it just like it is for now. And then use your little calculator to multiply 7/24 times 3/4. So that's 21/96. Right. And then now we're going to do kind of the same thing we've been doing, where we want to not have all these fractions. And so if you do what we just did, where you just don't reduce, just multiply across the top and multiply across the bottom, that 96, if you multiply through by that 96, is going to get rid of all of your fractions. All right. So I'm going to multiply 7/24 by 96. Now, if you have that little blue calculator, you can do 7 divided by 24 times 96, or 7 times 96 divided by 24. Either way, it is going to work out that is 28. And then the same thing on this. 3 divided by 4 times 96 is 72. Or 0.75 times 96 is 72. All right, here in the denominator, obviously that's going to be 96, and that's going to be 21. Okay, and then 28 minus 72 is -44, and 98 plus 21 is 117. Okay. All right, we're going to do one more, and it's C, that is the cosecant of u minus v. Okay, so we don't have a rule for cosecant or any of the reciprocal functions. So we're going to start off and we're going to find the sine of u minus v, and then the answer is the reciprocal. All right, so I know my cosine of u and v and my sine of u and v, so I'm just going to take those and I'm going to plug them in. And then multiply across my numerators and across my denominators. Whoops. And then when I subtract, I get negative 44 over 125. And that is what the sine of u minus v is. I want the cosecant. So it's going to be negative 125 over 44. Now, in the past, on the challenge exam, which they may change it, I don't know, these are the types. Sorry, this has been the most interrupted video I think I've ever made. That's okay. But anyway, what I was saying on the challenge exam, these are the types that I have seen with the sum and difference formulas. Now, luckily, they do give you the sum and difference formulas and a lot of these new ones we're talking about on the reference sheet, so that's good. All right, and because these take a little bit longer, because on those first ones you have to find all three. Your assignment is a little bit shorter.